Chapter 11, Industrial Development. There are your content objectives for the 4 key issues of this unit. Today's content objective: where are industries distributed? ICANN Statement 1. Explain the origins of the Industrial Revolution, important characteristics, and the diffusion to major industrial regions. 2. Describe the locations of the principal industrial regions. 3. Describe the major industrial regions in North America, Europe, and East Asia. And lastly, discuss new industrial regions emerging today. We'll touch on that last and more in key issue 4. All right. Industry means manufacturing. Think of them as synonyms. Where did it begin? The origin is in northern England or southern Scotland in the second half of the 18th century, so the 1750s. Industrial Revolution means the reform or change to industrial technology, transformed from process of manufacturing. Keep in mind, most industrial production prior to the Industrial Revolution in southern Scotland or northern England was geographically dispersed across the landscape, and most of the homes were creating the home-based manufacturing known as cottage industry. Here is a look at factories that were in United Kingdom during the Industrial Revolution. You can see the landscape is dotted by smokestacks, factories, and clustered buildings. Cottage industries, again, took place prior to the Industrial Revolution. When the Industrial Revolution began, the catalyst was the advancement of technology, specifically the steam engine. Now, steam was invented by James Watt in 1769, but the steam, what it allowed, was a constant power source for engines to complete the process in one building across for an extended period of time. So the steam, again, was the first time where you could harness it in a building for a long period of time and sustain that energy to manufacture output. The first industries of output was iron. They were, again, ovens that had to maintain a constant heat. And again, that was something that the energy of steam was able to do for manufacturing iron products or output. Then came textiles. Textiles were like the spinning frames in factories near sources of rapidly flowing power. So they had constant power from usually water sources, rivers, and they were to use these large machines that many households were not able to keep in their house to manufacture high numbers of outputs of textiles, clothing, shoes, rugs, linens, etc. And then the energy will, we should probably go down to chemicals, because then chemicals are added in the 1750s, where they're able to create a color dye. Sulfuric acid that's obtained from the burning of coal produces another acid called vitriol, which is used for coloring clothing. Now you have variety of clothing. Now you have the beginning of commercial manufacturing, where people are now buying from a factory instead of making it in their house. And then the other noteworthy step in the evolution of the Industrial Revolution is food processing. Now you can can food to help feed the factory workers, and the food would have a longer shelf life. Transportation, we'll see first with the railroads. Will be the first canals. They'll be able to bring large, bulky raw materials such as iron ore and coal. And coal is going to be mainly used for factories and transportation during this time. This will create industrial clusters in the world. This shows you the transportation at the world's first railway and the Stockholm-Darlington Railway. It opened in northern England in 1825 when the railway's centennial was observed in 1925. The original locomotives were still there. Here shows the diffusion of the Industrial Revolution. So we can see it in United Kingdom, where it diffuses to all parts of United Kingdom. And then it diffuses what shows here in the map about in 1836 into the other parts of Western Europe and in Northern Europe, but primarily it spread to northern, Western, and Northern Europe, where it didn't spread to the South, um, primarily because of political turmoil. And that delay will last for, as you can see in the map, nearly 40 years before we'll see industrial revolution spread to other parts of Southern Europe. So that will tell you areas of the world that are more developed today. When we go back to our development unit, these areas will be more developed because of the diffusion of industrial revolution happened there first. All right, here's a look at some of the technological advancements. When we look at railways, now we see the metal industry creating longer and stronger bridges and to reduce the need for stone, so you can put them up faster. So again, extending railroads and diffusing railroads much quicker during the Industrial Revolution. Here's a look at a locomotive or a rail line and faster transportation with rail lines and large container boats made movement of bulky products like iron, coal, and bulky material of textiles to locations much quicker. Here's a look again at the steam engine and the construction of steel bridges. And again, the bridges are you're able to increase manufacturing of the industrial output such as steel, and then you're able to haul it by these transportation ships or locomotives. And now with more efficient bridges being constructed, now we're able to expand, and now during the Industrial Revolution, you're able to expand transportation networks very quick. All right, take a moment to review what we've discussed. All right, let's talk about the industrial regions of the world. There are three regions where we have, first, Europe was the first to industrialize, and then North America will come about 100 years later. And when it came to America, it came a little bit later, but it grew much faster in the 19th century, so the 1800s, and it was concentrated in the northeastern part of the United States and southeast Canada. Then we see East Asia. East Asia will be led by Japan in the early 1900s, so the 20th century, and then China will emerge as the largest manufacturer in the world by the turn of the 21st century. So really we see industry concentrated in three regions of the world. And we also have emerging regions such as Brazil and India today. Those regions would be a part of BRICS, and those regions are outside of Europe, North America, and East Asia. All right, here's a look at Europe. And when we look at Europe, we can see that there's clusters found with industrial hearths such as United Kingdom. The United Kingdom has declined. The Mid-Rhine is important because it's centrally located. You have the Rhine-Ruhr Valley, which is the highest concentration of iron within Europe, and it also has the largest port. St. Petersburg is the second most specialized city in Russia. Then you can look at some of the new industrial hearths, such as in Spain. It's the fastest growing in the 20th century, specific in textiles and motor vehicles. Then we can see other emerging regions, such as Silesia, which is an emerging region in Eastern Europe. It's rapidly growing in the 21st century. So again, we can see the clusters of industrial manufacture. We see clusters of buildings, and we also see clusters of use of energy, and then also clusters of pollution. All right, here's another look at it, just a different picture. All right, take a moment to reflect. All right, when we look at secondary sector manufacturing jobs in the world, we can see the distribution is most heavily concentrated in the northeastern part of the United States and a little into the south. Then we look at Europe, primarily in the north and the west, or I'm sorry, the north and the east now. Then Russia has clusters of hearths, and then we see in China, in Japan, in India, and then outlining regions such as Brazil. here's a look at North America. Our old industrial hearths were in the northeast, and then it diffused along the waterway through the Great Lakes because of transportation routes. Eventually, they're going to continue to move east in search of iron ore or coal. Eventually, it'll take them to Minnesota, which in the Iron Range, the Messiah Iron Range, where they'll extract iron ore, and that will deplete in about the 1950s. It'll deplete to levels where we can now import iron for a cheaper price. All right, and then we see the shifting of industry to the southwest with major cities of San Francisco and Los Angeles. And think of Los Angeles as food processing, also textiles, specialized textiles, and then furniture. All right, here again is a closer look, a large-scale map. First industrial centers, again, New England, Mid-Atlantic, Pittsburgh, and now recently Southern California, Canada, the St. Lawrence River. These regions aren't as important anymore, industrial centers. Most of our industry has relocated to the south or to California or abroad. Quickly review. All right, emerging industrial regions because of site and situational factors. Japan in the 1900s was because of site factors, low cost, and also the advancement of technology. The first to industrialize in the East formed the Asian Tigers. Those would have been Hong Kong, Singapore, Japan, and South Korea. And those are industrial advanced countries today, post-industrial advanced countries today. Then we see the emergence of China in the late 90s, so the end of the 20th century, the emergence of the 21st century, where their site factor is cheap labor, low-cost labor, and today they're the largest manufacturer in the world and the largest consumer of steel in the world. All right, here's a look at the distribution of industrial hearths located in China and Japan and South Korea. We can see that there's, again, industrial clusters near Beijing and Harbin in northern China. Then you have Shanghai along the Yangtze River, and then in the south with Hong Kong, Guangzhou, and Shenzhen, and this is near the special economic zone of China. Then South Korea in the south, and then clusters near Tokyo and in Osaka. New industrial regions, India, 1/5 of the world's manufacturing in the world, fastest growing in the world. They manufacture textiles, steel, and telecommunication. Remember, when a country industrializes, the first outputs they'll create are steel because of infrastructure, and textile because it's labor intensive and it's fairly low skilled to manufacture. Then Brazil is a large agricultural exporter and a fast growing manufacturing or secondary sector. Right. Again, quickly review what's been discussed. All right, let's continue on with key issue 1. Why are site and situational factors important in industrial production? Keep in mind that, as pointed out in Rubenstein's 2016 text, for nearly all customers, low price is more important than the place of origin. So now when we look at site and situational factors, these can be some of the most crucial geographical factors for locating an industrial factory. So for this second part of key issue 1, ICANN Statement 1, identify and explain 2 types of situational factors. 2, explain why some industries locate near inputs. 3, explain why some industries locate near markets. And 4, explain why industries use different types of transportation. The 2 geographical causes are situational factors and site factors. Situational factors, think of it as a place in reference to another place, like we learned in Unit 1. Transportation is the most important factor in situational costs. What kind of transportation and what form of transportation, how far, is going to be a situational factor that's very important when we look at location of industries. Site is the other important factor when looking at industrial location. Those are costs that are unique to the materials and labor. So again, the site factors are going to be unique to cost, labor, and also capital. Contemporary manufacturing is spatial disaggregation. So we know that in contemporary factories, there is, again, specialized scrutiny to where they put factories. Most of them are going to be located near markets. However, now with advanced forms of transportation, some are found in locations that aren't necessarily near markets. So we see spatial disaggregation. Site factors, we have to be mindful of minerals. Site factors such as raw materials or land are minerals. And we think of minerals, Earth has about 92 natural elements, and 99% of the crust is composed of 8 of them. So the eight most abundant common elements combine with less abundant elements to form approximately 3,000 different minerals. Many of these minerals fall within non-metallic minerals, such as 90% of all minerals that humans they're non-metals. So they're diamonds, gemstones, minerals, fertilizers, nitrogen, phosphorus, potassium, calcium, sulfur. There's also metallic minerals, and those are used for fashioning machines or vehicles. They're malleable and are good conductors of heat and electricity. And then we have many metals are able to combine with other metals. Those are called alloys, where you're able to combine with other metals. Those are known as ferrous and non-ferrous. So ferrous alloys, iron is extracted from the iron ore. And ferrous alloys include, it's the most widely used by humans. It's an important metal, and other ferrous alloys are like chromium, magnesium, nickel, tin, titanium, and tungsten. And then you have non-ferrous alloys, and they don't contain iron and steel. Those are other less durable and more malleable irons, such as aluminum, copper, lead, lithium, magnesium, zinc, and precious metal. Few important minerals are found in Europe, Central Asia, Southwest Asia, and North Africa. How will this site factor affect development? Well, it'll have definite development on industrial development, because a lot of these minerals are used for either energy or materials for creating output, and it will increase the standard of living. Well, then you might ask, well, why is Europe that has relatively minimal site factors with land so advanced? Well, I think colonization. Here we look at site factors with labor. Site factors, labor is probably, in your textbook it says it's the most important factor for industrial location. So on a global scale, industrial manufacturers are trying to minimize labor costs. And we can see where labor is very expensive. So wherever we see the developed countries, they're going to be found in what is known as very low labor intensive industry. These are going to be high labor intensive industry. Industry where the wages and other compensation paid to employees constitute a higher percentage of the expenses. So for instance, labor constitutes about 11% of overall manufacturing in the U.S. So labor intensive industry in the U.S. would have a much higher percentage than that. The reverse is true of industries in lower than average expenditures on labor. So these areas are known as capital intensive. More money is spent on capital than on labor. These are going to be labor intensive industries where less money is spent on capital. Capital is going to be, think of it like tools and advancement in technology and communication. Here we see site factors in Silicon Valley. These are going to be capital intensive. Secondary manufacturing. It is not going to be labor intensive. They're going to follow a post-Fordism production, meaning they're going to follow a plan that's lean, flexible, and and there's a problem-solving team where they work together to find a consensus through dialogue, and there's advanced computer literacy, and the requirements in these jobs are college degrees. So again, when we look at Silicon Valley, this is capital. Money is spent using to build the technological advances in Silicon Valley. Well, why is Silicon Valley headquartered where it is? Well, financial institutions in Silicon Valley have long been willing to provide money to software and communication firms. Whereas in the 20th century, most of the money was concentrated in Michigan, and most of the regional financial institutions were giving money to Michigan or Eastern Coast, and they're unwilling to give money to the West Coast. So when we look at, well, we also look at Silicon Valley, roughly 2/3 of the high-tech industries fail. But we also see 1/4 of all the capital in the United States is spent on new industries in Silicon Valley. This is a critical factor when you have a capital intensive labor force, because you can advance the technology and capital. Whereas if you're labor intensive, you can't. Majority of the wage has to go to the worker with low skilled manufacturing. Here's a look at site factors, and we can see that the Model T in Michigan, so a lot of bank loans from the east were going to Michigan for the advancements of technological production of motor vehicles starting in the early 20th century in the Model T. And we'll also start to see a process that's common of industries in the 20th century, where they use an elevator to bring the parts up to the highest level of the building, and then they build it as they come down the building, and the final product would be on street level. Situational factors. Remember, we said transportation is important for situational factors. So we're looking at proximity to inputs is going to be important. Those are going to be bulk reducing industries. They're close to the coal or the copper or the bulk material energy or minerals. So they're reducing the weight, so transportation cost is cheaper because it weighs less moving in transport. Second situational factor is proximity to market, which we see more of industrial manufacturing in the 21st century with proximity to market. These are going to be bulk gaining. They use different forms of transportation, which is called break bulk of point, and then they'll amass weight near markets. So when it's the product's weight its heaviest, the transportation is cheap because it's traveling a very small distance, usually within a 60-mile radius of an urban center. Here's a look at situational factors. Copper is a great example of bulk reducing, but the whole process is not bulk reducing. Most of the process is bulk reducing when we look at copper. When we look at the concentration, well, first you have to mine. When you mine, you're now breaking the bulk, or you're taking heavy, bulky ore, and you're getting rid of the waste, which is known as gauge. And then you concentrate, which is the second step. That's crushing the material into fine particles. Then you smelt, and that's removing the impurities. These are all located near the input, so near the copper reserves. And we can see most of the copper mined in the U.S. is in the west, in the foothills of the Rocky Mountains. Then there's the refining process, but when we look at refining, they're always near smelters. But then what happens with copper? Then it's shipped where they're going to manufacture the copper across. And when we see, does it show? It doesn't show the manufacturers, but manufacturers will be in major urban centers where the copper is used to produce whatever manufactured output. So it's a combination of steps. Most of the first 4 steps are bulk reducing, and the final step, manufacturing, is bulk gaining. All right, and then we can see 2/3 of all copper is found in Arizona. All right, so here's Arizona. You can see the high distribution of the dots, or the high arithmetic density of the dots. All right. Looking at important minerals for industry are found across Earth's surface. They're not uniformed. as I already talked about with non-ferrous and ferrous metals. Remember, ferrous metals are, you're able to combine metals to other metals. Those are called alloys. And those are very important because they're mostly used for hand tools and weapons and other manufactured goods. And then we have the non-ferrous metals, and those don't contain iron or steel. And those are going to be like your aluminum, your copper, gold, precious metals. All right, take a moment to review. All right, let's take further look at bulk gaining. Bulk gaining is the most common form of industrial location. Bulk gaining is when the product weighs the heaviest near the market. So production plants are usually near markets to reduce the cost. An example would be bulk gaining of fabricating metal. It's fabricated metal, the fabrication of parts and machine from steel and other metals. They're fabricating metals are located near markets because they can use scrap metal and then scrap metal is abundant. So when you're creating the bulk gaining fabricated product, it's much heavier near the market. Beverage bottling too is going to be near markets where they fill the bottle to add weight, and so it's cheap in transport near markets. And we can see situational factors located near population concentrations, then located near major cities in the West. So again, minimizing transportation. All right, here's a look at automobiles. When we look at motor vehicles, today 90 million vehicles are sold annually worldwide in 2020. China accounts for 20% of them. China accounts for 30%, North America with 20%, Europe with 22%. Looking at the United States, we have the production along what is known as Auto Alley. Auto Alley is a situational factor that runs down the central corridor of the U.S. And this central corridor now where we construct most of the motor vehicles. So it's clustered between the state of Michigan and also down in Alabama. So it's along that central corridor, and here we can see Honda plants are found in that Auto Alley using situational factors. And now most of vehicles, even though most vehicles are made in the U.S., but most of the assembled parts will come from abroad, come from other countries, and then brought to Auto Alley where they'll assemble a vehicle and say made in America by adding bulk gaining weight and then transporting the shortest distance to both the coasts. We look at the 90% of vehicles made in the world. China is the global leader in vehicles, followed by Europe and then North America. Again, when we look at the nationality of manufacturers, it's less likely to be local. So in 2017, 64% of the world's sales were either in North America, Ford and GM, Germany's Volkswagen, France's Renault, and Italy's Fiat Chrysler. And then East Asia, where we see Japan and Toyota and Honda, and South Korea's Hyundai. Here we look at Honda plants. Single market manufacturers, these are going to be specialized manufacturers. So they're going to have one or two customers, like the YKK zipper. It's going to be located in 68 countries. It's going to have usually the manufacturer or clothing industries will buy that, so that's their one or two customers. And then we see more recently with motor vehicles. Independent parts makers supply 70% of the value of most GM and Honda goods car makers, where they account for 30% of the value of the vehicles, but independent parts are shipped from all over the world, and their specialized part shipped to GM and Honda, where they'll manufacture vehicles in Auto Alley. Here's the YKK. Other situational factors are perishable products. These are perishable or expiration dates, so they have to be in your market. So printed newspapers, perishable baked goods, or milk. Again, milk with the milk shed. Here's potato chips. All right, take a moment to review what's been discussed. All right, then we get to transportation, ship, rail, truck, or air. The mode of transportation is very important because the cost per kilometer decreases for each of the four models. So oftentimes companies or large industrial manufacturers will use break, bulk, and point. They use many modes of transportation. Trucks are used for short distance, usually one day, without any stopping time. Trucks, again, will travel usually that 60-mile radius within the beltline of an urban center. Trains are also used, and then trains can be found extending from the east and west coast, usually from container ships that go to ports. And when they go from ports, they go to urban centers or major cities. Then we have airplanes. Let's go ships. There's many types of ships in break, bulk, or point. There's container ships. Those are large container ships that bring products abroad to coastline and major manufacturing centers. Then they'll put them on container rails, and then they'll ship them across to urban centers across the United States. And then there's also break, bulk, or point, which is used for other forms of railway transportation. These are going to be freight companies that will bring freight into central cities and ship from there. We also have break, bulk, or point used with airplanes. Air freight companies pick up packages in the afternoon, transport them by truck to the nearest airport, to the central hub located in Memphis, Tennessee, or Louisville, Kentucky, and then they'll be flown to airports nearest their destination and transferred by trucks and delivered the next day. So break, bulk, or point can be used with airplanes. It can be used with boats or container ships. Most bulk manufactured goods will use the container ships, break, bulk, or point. Keep in mind, when you change transportation, it does increase costs. So again, this is very important to industrial manufacturers in their location. They have to be very aware that the costs come from unloading, reloading, storage, and movement, taxation, tariffs. All those have to be weighed into deciding a location. One of the largest transshipments and entrepots in the world is Singapore. So Singapore is a large area, or is an area where they have transshipment, where they house or they store large containers within the containerization of shipping bulk goods by large container ships. Here's a look at truck freight as it moves throughout the United States. Shipping occurs across the world mostly by shipping routes, those container ships, extremely large bulk carrying container ships. And we can see where the container ships are mostly going, from China to other parts to the U.S. And then also parts of Southeast Asia to Southwest Asia and to Europe. So you can see most of them are going to the U.S., Europe, or Southwest Asia. Here's a look at the Port of Los Angeles' break, bulk, or point. It's the largest port on the West Coast, and container ships. You'll see these large boats, container boats that come in. They'll arrive. They'll have large cranes, and the cranes will take the shipments, these large cargo box cars, off the container ships and put them on rails and ship them along railways to outlying rural areas, and then from there they'll put them on trucks. Just-in-time delivery it's usually used within delivery of inputs. It arrives at the factory the moment it's needed for parts and raw materials. A lot of these can be fabricated products, such as cars or computers, where they put parts together quickly, and the parts arrived within the time it's needed to assemble a final product. It reduces the money that a manufacturer must tie up in wasteful inventory. It also reduces the size of a factory. Just-in-time delivery can be disastrous for natural disasters, poor weather, closing of highways. It can be traffic, delays in traffic, or strikes, labor unrest. Here's a look at the world shipment routes, which we already saw. All right, again, the various costs that you look at for when you use break bulk of point, because there are costs that rise with every portion that break bulk of point, such as freight costs, transshipments, and terminal costs. Here's a look at a container ship to Maersk, if you want to watch that. All right, in review. That'll take us to the end of notes.